welcome back, guys. This video will be taking a look at sine graph and its properties. Though this is a very poor representation of the sine graph because I'm not drawing to scale and I'm a little bit poor when it comes to drawing. But I will explain what the graph is all about so that you understand all what our sine graph is all about. Now, from what you can see here, this was also be drawn to scale in such a way that the distance from here to here should be equal to the distance from here to here, because this is 1 and this from here to here also is -1, so it should be having exactly the same distance. So I drew bare hands. So we're starting from this mark here. At this particular point, we have here to be our 0 mark. So you can see here that our sine 0, this is the axis of theta, this is the axis of theta, and this is the axis of sine theta. That's x and y axis. This is theta and this is sine theta. I can say this is simply a function of y is equal to sine theta, where your x is theta and your y is simply sine theta. So my sine 0, from what you can see here, when theta is 0, sine theta is also equal to 0. So I can put that here. When theta is 90 degrees, sine theta is equal to 1. When theta is 180 degrees, sine theta is equal to 0. When theta is 270 degrees, sine theta is equal to -1. When theta is 360 degrees, sine theta is equal to 0. And from this point henceforth, it is repeating itself. So this is 360 behaving exactly like 0. So everything from here down to 720 will behave from 0 down to 360 exactly the same way. So that's just another revolution. 0 to 360 is equivalent from 360 to 720, equivalent from 720 to whatever 720 plus 360 is. I think that's 1080. That's 1080 degrees. So that's that for this. Now let's go to the negative side of of our sine theta. This is, if here is 90 degrees, here has to be what? Minus 90 degrees. So sine minus 90 in this case is -1. So I can put here -1. Sine minus 180 is 0. Sine minus 270 is +1. And sine minus 360 is 0. So there are a few things that we can observe from what we just did. And one of those things are your sine theta ranges from -1 to 1. So if I'm to write that using inequality sign, I can say our -1 is less than or equal to sine theta less than or equal to 1. So therefore, sine theta cannot take any value, any real value that will give it a value greater than 1 or a value less than -1. So sine of any real number will either be or will always be between -1 and 1, or equal to -1 or equal to 1. It cannot be greater than 1. It cannot be less than -1. So that's one of the properties of sine theta. Then the other property, you will observe that sine 90 is 1, sine minus 90 is -1. Then sine 270 is -1. However, sine minus 270 is 1. So I can write here that sine minus theta is always equal to minus sine theta. Sine minus theta is always equal to minus sine theta. So let's check that out. Sine minus 90 is -1. So let me put that here. Sine minus 90 is equal to -1. Then sine 90 is equal to 1. So -1 and 1, they are not the same. But what is minus sine 90? If sine 90 is 1, minus sine 90 is -1. So I can boldly say that sine minus 90 is equal to what? Minus sine 90. That is, sine minus theta is equal to minus sine theta. We can also check with 270. Sine minus 270 is equal to 1. sine 270 is equal to minus 1. So I need to make these two guys to be the same. So if sine 270 is minus 1, minus sine 270 should be equal to minus times minus 1, which will give us 1. So I can boldly say that sine minus 270 is equal to minus sine 270, which holds that sine minus theta is equal to minus sine theta. So that is another property for sine theta, and that will make us establish the fact that our sine theta is an odd function. Sine theta is an odd function because odd functions are functions that obey the rule that f of minus x is equal to minus f of x. So any function that obeys this rule, f of minus x is equal to minus f of x, is an odd function, making sine theta an odd function. So I believe that's all we need to learn concerning our sine graph. So these terminal values, now you know them, in addition to your special angles: sine 0, sine 90, sine 180, sine 270, sine 360. Now, just based on what we've learned so far, let's say you come across a question like this: what is sine? Okay, let me drop it. Here. What is sine minus 135 degrees? What is sine minus 135 degrees? Now, because this is a negative degree, we have to change it to positive degree. So sine minus 135 degrees should be negative sine 135 degrees. Now, what is sine 135 degrees itself? This is falling in the second quadrant. So in the second quadrant, we have to change this guy to sine 135 will simply be sine 180 minus 135 degrees. Sine 180 minus 135 degrees, because we are working in the second quadrant. 180 minus 135 is 45. So this is sine 45 degrees. Remember, in the second quadrant, your sine is positive. In the second quadrant, your sine is positive. So sine 135 degrees is equal to positive sine 45 degrees. Sine 135 degrees is equal to positive sine 45 degrees, and that is simply root 2 over 2. But we are not looking for sine 135 degrees. We are looking for negative sine 135 degrees, because this is sine minus 135 degrees. Sine 135 is root 2 over 2, but negative sine 135 degrees is minus root 2 over 2. So therefore, sine negative 135 degrees is minus root 2 over 2. So this will be drawing the curtain. Now, next video, we'll be looking at cosine graph. If you enjoyed this video, kindly use the like button, and don't forget to subscribe if you are yet to do so.